Nuclear waste, it is a huge, huge problem, and I bet you don't realize how bad a problem it actually is. I'm Michael, I forget my name, you know what happens. I'm Michael Krigsman, I'm an industry analyst and the host of CXOTalk, and today on episode number 302, we are speaking with two people who are trying to change the way the world disposes of nuclear waste. Now, before I introduce our guests, right now, please subscribe on YouTube. And I want you to tell your friends to watch as well. So our guests today are the CEO and the Chief Technology Officer of a company called Deep Isolation. It's very unique because it's a startup that is trying to take on the government and nuclear power plants and change how we dispose of nuclear waste. It's an audacious and bold problem that they are trying to solve. And so without further ado, I want to introduce Liz and Richard Muller. Liz, how are you? It's great to see you. Tell us about Deep Isolation.
Thank you, Michael. So the nuclear waste problem that we're trying to solve is, as you said, it's actually a really big deal, even though many Americans haven't heard of it, don't know about it, and are unaware of the current situation. So we have here a nuclear waste pellet, not a real one, but an example of what spent nuclear fuel looks like. And the important thing to keep in mind is that this would kill you. It would take what?
Well, if you were exposed to it for about a minute, and that's it, you would probably die within an hour.
That little thing?
Well, not this one, but yeah, these pellets, they come out of the nuclear reactors. This is the form in which they come out of the nuclear reactors. It's not a oozy green sludge. It's these little ceramic pellets, but they are exceedingly dangerous. The gamma rays come out and they explode.
And then also important to know is that we have 80,000 tons of these pellets all around the United States in about 70 locations. And 1/3 of all Americans live within 50 miles of this spent nuclear fuel. It is in temporary storage, so it is, we think, safe in its temporary storage, but it has always been meant to be temporary, and there is no disposal facility for spent nuclear fuel that exists right now in the United States. And it's been really hard to move forward any sort of plan to actually move into action on creating a disposal facility.
Now, I want to ask you about your technology solution and then turn to the business aspects. But before we do that, so let me ask you a maybe an impertinent question. Given the extent and the size and the complexity of this problem, frankly, what makes you qualified to solve it?
Well, we have a background in both the drilling technology and in the nuclear technology. And it's because of this that we've been able to recognize this is really a tale of two technologies. The original plans for disposal were conceived of in the 1970s and 1980s, and this was locked in. We go ahead, it's going to go to Yucca Mountain. But in the last 20 years, there have been absolutely amazing developments in the drilling technology. And the fact is, this fuel, even 80,000 tons of it, is actually compact enough that we can put it all down into 300 drill holes underground. Drill holes of the kind that we weren't making 20 years ago, but which now have become a commodity. These are the sorts of things you can drill at relatively low cost. Every drill hole has a volume capacity of about 100 cubic meters. So there's plenty of room for this extremely compact nuclear waste.
I'll also just add that the government has really failed to deliver a solution. Now, there is potential that Yucca Mountain might be restarted, it might move forward, but it's going to cost $100 billion. I mean, the government has been unable to solve the problem. The big industry has not come up with a solution. And we think that this is a space where a startup company with private funding can do things faster, we can be more nimble, we can do things in a way that nobody has been able to do it in the past.
Richard, I know that you are a scientist and have developed very interesting techniques associated with that. And you've also been able to get on board very leading thinkers in the world on this approach. And so would you describe a little bit about your background as well as the folks that you have on board?
Well, I like to start up projects. So in my past, I have founded several fundamental research projects in physics that led to great discoveries.
It led to Nobel Prizes for the people that he handed off to.
Yeah, so these had to do with astrophysics. They had to do with practical things, with radioisotope dating. I invented the method that is widely used now for most radioisotope measurements. So I've had this long background of founding big, successful projects, and I think I know how to do that. I've also worked very deeply for a very long time on urgent U.S. national security issues. So this was working closely with the government to help them move forward on problems that were really challenging them. I regard the future of nuclear power to be of this waste to be a national security issue. This is really an important thing, which is now mired down in politics and not taking advantage of the developments of technology of the last 20 years.
So is this primarily a technology or a political issue?
The basic idea is technology. The technology is so compelling that we're able to bring on board these world-class experts who say, wow, well, this is the solution that we were looking for. The challenges tend to be largely government, regulatory, and political.
So in terms of our company, I would say we're about 1/3 technology, 1/3 political government, trying to get a pathway through the government so that we can be a business, we can actually dispose of the waste. And 1/3, I would say, outreach to communities, to environmental groups, making sure that we're doing something that really works for everybody who's going to be impacted by it. And by everybody, I really mean everybody in the United States and the world, because we're all impacted by nuclear waste.
So presumably you've taken these three pieces because the technology, the policy and politics, and then community acceptance are the three components that need to be in place in order for this type of solution to ultimately be accepted, be adopted.
And they all influence one another too. So the feedback and the conversations that we have with the public and with environmentalists can influence the design of the technology. And so it's not just separate silos. This is really three pieces of a cohesive whole.
So, for example, because of our interaction with the public, learning what really concerns them, what doesn't, we are starting an initial program where the nuclear fuel will, at the nuclear reactor, the fuel is stored at the reactor where it was burned, this radioactive waste, 2/3 of it in just pools inside concrete buildings. We can take that fuel and we could bury it deep underground at the very location where it exists with no transportation across the state. We hadn't realized how important this was until we did our public surveys, and we discovered that not in my backyard means don't bring your garbage into my backyard. But if my nuclear material is in my backyard already, then rather than transport it out of our state across our highways to our towns, bury it deeply right where it is. So this is how the public information has really affected our technology.
Can you describe how you apply oil fracking techniques to your novel solution for the disposal of nuclear waste?
Yeah, what we're doing is using the technology that's been developed, but not the fracking. So we don't frack. A lot of it we don't use. But in the shale oil and gas recovery, what they do is they drill down typically a half a mile, maybe a mile, and then they curve the pipe. That's amazing to think that the pipe can be curved, but the curve is so gradual that even the steel casing they put down there can bend around that. And then they go horizontally into a shale formation. Shale formation has held natural gas for tens to hundreds of millions of years. Our thought was, what an ideal place to put something that you're worried about. You're worried that this nuclear waste will continue to be dangerous for tens of thousands of years. Let's put it in or under a formation that has held even gas for 10 to 100 million years.
It's a great starting point for knowing that nothing's going to get out.
What gave you the idea to apply this technique, to develop this technique and apply it to this problem?
Well, we had a background in shale drilling. We'd spent some time, particularly in China, because they have this horrendous air pollution problem. And if they can switch from coal to natural gas, we will literally be saving millions of lives. And 1.6 million people die every year in China from air pollution. So we had this background in the drilling technology, where we're working with people in Texas and elsewhere that are really experts. But we saw the nuclear waste issue as being one that is unsolved, and we began to educate ourselves on that. And then suddenly we realized we can put these two technologies together, that one offered the solution for the other. When we talked to people in the nuclear business and told them about the drilling technology, their typical reaction was, well, if you put something underground, you can't get it back up. It's a legal requirement that you be able to recover this. And we'd say, no, you recover it all the time. The people do this. They even have a nickname for it. They call it fishing. And there are companies that specialize in fishing. So the problem was there was nobody who knew both of these technologies, and we did.
Yeah, the current designs for nuclear waste disposal, which haven't in the US been actually implemented, but the designs are all from the 1980s or earlier. And we've come a long way. There's been a lot of innovation since then. And so we're now being able to take a fresh start and say, okay, if we were to start from scratch today, is there a way that we could do it that would be safer, cheaper, faster, and easier to implement? We like the fact that it's distributed, that it's modular, rather than having a single central repository.
You know what's really interesting to me about this, one of the aspects is, I talk to a lot of startups, and almost all of them describe how they have a revolutionary approach to something that's going to change the world. And you guys really are trying to change the world.
Well, we think so, but sometimes we're concerned that everyone thinks so. So maybe we don't actually. But I think
So how much of this? So you're a startup. You've raised some money. You're looking to raise more money. How much of this, and your market potential is in the billions potentially. So how much of this is about mission for you, and how much of this is about basically the money and starting a business?
Yeah, so I think the first thing to point out is the money is really there. This is the place where the American government has done, in some ways, the right thing, and have the utilities pay up front for disposal of nuclear waste. So there is a $40 billion nuclear waste fund. A little bit more challenging when you get into the details, but there is this $40 billion fund for the disposal of nuclear waste. And that is what our investors have been interested in. Initially, when we had the idea, we weren't sure we would do it as a startup company. We thought maybe we would do it as part of our nonprofit, which is what we've been doing together for the past 10 years. But as we looked at it, we realized, no, if you want to do something quickly and you want to do something big, the way to do it these days is, we want to be the next SpaceX. We want to do something really important that will shake up things, and the way to do that is through a startup company. So in terms of the money, I think personally our real interest is in solving the nuclear waste problem. That's why we got into this. That's what we've been solving environmental problems for the past 10 years. That's our passion. But in order to do this, we have to show our investors that they can make a 100x return on their investment. And so we are also, I would say, very focused on doing that. Our investors are taking a real chance on something that they believe in, something that we all believe we can do. But that's why we're also being really somewhat hard-nosed about the investment side of things.
So tell us about the buyer. Who is the ultimate buyer for your service? Is that the right way? It's not really a product, right? So I guess it's a service.
Yeah, so on paper, I think the only buyer really is the US government. And they do have ultimate responsibility for the disposal of nuclear waste. We're not looking to change that. We don't think that a private company can take responsibility for tens of thousands of years.
We are looking at other countries too, however.
Right. Well, we are looking at other countries, but same thing. It's the government. But I think that along the way, there are so many other people that are in some ways a client. So there's the individual communities, there's the utilities, there's many different pieces of the puzzle. So even though we say that it's the government that is fundamentally our client, they're not our only client. I mean, even the American public is in some ways our client.
Yeah, the people who, there's real pain on this issue. And the communities have pain, the utilities have pain, the government has pain, the regulators. So we are trying to really solve that issue.
From an investor standpoint, how do you convince investors that even though your technology is great, there's so much political headwind to overcome? So let's say that your technology is great and your solution helps communities avoid moving that nuclear waste across their borders, and so communities like it. But now you have the whole, now you're so deeply involved in the government and the politics. So how do you manage that, and what do your investors think about that? It just adds so much complexity.
Yeah, so about a year and a half ago, we were still primarily a technology company, and our investors came to us, or potential investors, and they said, we are concerned about the government side. How can you show some progress in the government side? So for the past year and a half, we have been really focusing on the government side, and we've hit some really interesting, important milestones along that way. We're finding support on both sides of the aisle. So Republicans like us because we are cheaper, we are private sector, we are innovative. Democrats like us because we're providing an alternative for people who don't want nuclear waste in their backyard. We're providing an option, not something that we're going to force people to go with. So we've been finding remarkable progress on the political side, which is not to say we're there yet. I think we still have a lot that needs to be done on the political side. But we've been having conversations at very high levels, and there is a lot of support for the work that we're doing. And investors get that. And I think that they understand that this conversation is happening at the right time, the right place, because Yucca Mountain has been stuck. And there is still some support, quite a bit of support for moving Yucca Mountain forward, but it hasn't been able to move forward. And we might be able to be part of a compromise that would allow multiple things to move forward at the same time. And any progress in nuclear waste disposal, we think, is genuinely good for everyone involved.
So would it be fair to say that your primary competition is Yucca Mountain?
You know, we don't see Yucca Mountain as competition because, again, I think any progress on Yucca Mountain would help us as well. So we're providing an additional option. There are some places where we could not dispose of the spent nuclear fuel on site. So Yucca Mountain is needed for some locations. There's other places where it might be really challenging to get the fuel from where it is all the way to Yucca Mountain with people in between who don't want it to go through their land. So I think that we're very complementary. I mean, you could say that we're competition, but I don't really see it that way. I see it as the more the better, and we need all the options we can get.
Yucca Mountain, by law, is limited to 63,000 tons of nuclear waste. Of spent nuclear fuel. And there's already almost 80,000 tons. So we need more space. Well, I think of us more as a supplement to Yucca Mountain, something that would be very attractive to people, particularly spent nuclear fuel, nuclear waste, that's very distant.
And we can also move faster too. So that's another.
So you say Yucca Mountain is limited by law to 63,000, and yet there's 80,000 tons?
Almost 80,000, yeah. So they have to change the law to allow Yucca Mountain to grow bigger, or they could change the law to allow the study of a second repository. We would like to be the second, the third, the fourth, the fifth, the sixth, the seventh, eighth, ninth, the 10th. And
what about, tell us about the safety issues and also the economics of your solution.
So in Yucca Mountain, you put, and in almost every facility around the world, you dig deep tunnels, you put people down these tunnels, they put the waste in place. In our facility, nobody goes underground. We put the waste in capsules that are maybe 12 inches in diameter, 15 feet long. These capsules are lower down into these drill holes, deep down, far deeper than anybody else is proposing, and then put horizontally. So they're sitting next to each other. It's spread out, and it's underneath 1 billion tons of rock. So none of the radiation gets out. The only thing we have to worry about is that someday this capsules will be corroded, and we can make capsules that will last 10,000 years. And when they get corroded, then the geologic barrier is enormous. Water down at this depth, we're way below the aquifer, far below it. Much. Yucca Mountain, for example, is above the aquifer. They worry about that a lot. We are so far below it where the water is essentially immobile, and it just doesn't come to the surface for millions of years. So it's really the safest place to put it.
And now the economics, and then we have some questions from Twitter.
Great. So the economics, the drilling part is really the cheapest part of everything that we're doing. You can drill a hole that would be a great disposal facility for nuclear waste for a few $1 million. So, in contrast to 100 billion that you're looking at for a massive facility at Yucca Mountain. Now, we would need more than one hole for deep isolation. We're looking at potentially a few hundred holes if we were to do all of the spent nuclear fuel in the United States. But the drilling costs are not a major part. The licensing costs are higher. The process of transferring the waste from the spent the pools into our canisters, those are the things that are going to cost more. But in any case, we can't figure out any way that what we're doing would cost even half as much as Yucca Mountain.
Again, it's really interesting because you're solving for most startups, they're looking primarily at the economics. In your case, you've handled the economics completely, it sounds like, very thoroughly. And yet, so the challenge therefore reverts back to community acceptance, and then even more importantly, getting the government to do something.
That's right. The economics are overwhelming. I mean, it's just the difference in price between drilling a hole that's this wide and going deep and versus creating a underground repository with humans underground. I mean, it's just night and day.
No, the technology is, we're not doing anything spectacular in the technology. We are being the first ones in this business of putting nuclear waste underground. There's lots of opportunities for intellectual property, so we have been writing out patent applications for just because nobody else is thinking in this business. So that will help with the investment. But we think that the technology and the economics are really the strong points. And in fact, when investors say, well, I don't know, I mean, I know how to evaluate risks in technology, I know how to evaluate risks in economics. You don't have any. But this government stuff, that reminds me of the difficulties of the medical field in getting things approved. I don't know anything about that. So I'm nervous. And that's the kind of reaction we get from a lot of potential investors.
Yeah, that makes sense. So looking at medicine as a sort of analog for the level of regulation and concern over risk.
Well, part of, the advantage we have is that the issue is really urgent. This nuclear fuel is accumulating. It's on the surface in containers that we believe are safe. But the public is deeply worried about it. There are locations that simply refuse to have more surface containers because of what they perceive as the danger. Putting it a mile deep makes them very happy.
And nor do they want to transport it out.
Yeah. So I think we have there is this discomfort, and it's in the government too. The regulatory agency, the Nuclear Regulatory Commission, is actually a superb commission. It's bipartisan. The 3 members were just confirmed by the Senate. It was by unanimous vote. So these are really good organizations, but they also want to solve the problem. It's a good time. It's an urgent issue for the government.
We have a couple of questions from Twitter. Gus Beckdash says, his nuclear physics may be rusty, but can't we build reactors that recycle and consume the old fuel? So why aren't we just doing that and making the problem go away that way?
Actually, we are doing that. We're moving ahead really fast. 2 points about that. One is for the foreseeable few hundred years, none of this new technology would burn up all of the fuel that we have. And when it does burn it up, what it burns up are the long-lived radioactivities. It burns up the plutonium, which the public really worries about. But in fact, the waste from these reactors, even though they don't have plutonium, have more short-lived radioactivity, 30 years, strontium and cesium. They're much, much hotter radioactive from a radioactive point of view than is the waste we have now. So the getting rid of the waste problem doesn't go away.
And we have another question from Twitter, which is Arsalan Khan is asking, can't we use nuclear waste for something productive? Eventually, can't we do something with it that uses it since we have so much of it?
Parts of it are very productive. We use the americium in medicine a lot. We use it for producing industrial devices that can X-ray metals. So there is a lot of it, but nobody has figured out how to use it all. The parts of it that are just radioactive and very dangerous. And so the bulk of the material, I mean, I every now and then I say, is there some way I can take this waste, which gives us all this radiation, and use it just as a source of energy? And in principle, you can, but when you think of the danger associated with it, it makes it impractical to do that.
So fundamentally, then, from a technology standpoint, the issue is moving it, getting it away, and storing it so that it will be stable.
Yeah, this has been looked at. I mean, people always have these ideas. Let's send it off to the moon. Let's send it off to the sun, burn it up there. That would be great if you had 100% reliability for your rockets and the thing would never crash. So the significant committees that have looked at this all have come to the conclusion that the right place to put it is deep underground. We're talking about, if you look at the pyramids, they last for thousands of years, but not for millions of years. If you go down underground, you have structures that have been unchanged for 100 million years. This is the place that every major scientific committee that has looked at this in an objective, serious way has concluded this should be, geologic storage is the right way to do it. How do you do the geology? Do you build tunnels and drifts? Do you put people under there shoving these things down the railroad lines? Or do you do it remotely with nobody underground in narrow holes, which are really, you can recover the fuel from it, but it's a $1 million operation to recover the fuel, and it would take several weeks. So it's hard for terrorists to get to. It's very unlikely to be hit by inadvertent intrusion, and it is safe. And this is what every committee has concluded.
So the accepted scientific wisdom is it needs to be buried, and therefore the question becomes, or is this the question, what's the most efficient and way of doing so that remains effective?
That's right, and what we know about that has changed over the last 30 years.
The consensus is that it should be deep geologic, right? So it needs to be deep. It needs to be in a place where the geology is stable and hasn't changed for a very long time. Within that, there's quite a bit of flexibility. So a Yucca Mountain type of approach is deep geologic. Deep isolation is deep geologic. So there's some flexibility in what sort of deep geologic, but the consensus is that's what's necessary.
Some people have proposed putting it in large salt domes, for example. And there's a facility in New Mexico that does.
And vertical boreholes was a
vertical
previous
boreholes
program.
was a previous program. So their ideas are still coming around.
Yeah.
We think our idea hits all the right notes.
And you're confident in your idea because the method of drilling has been developed and refined in the oil and gas
Well,
business.
that's one of the reasons we're confident. But of course, the real reason we're confident is that we have talked to every expert we can find. And they always look at us with a smile of skepticism as we come in and we say, we've solved the nuclear waste problem. And we go out with people saying, this is wonderful, how can I help? So we know the experts. We know we've talked to not every expert in the field, but we've talked to a lot of them and gotten their comments and their thoughts. And often their thoughts are, well, here's your technical solution will work. Here's my suggestion on how to get it through the government.
Well, let me ask you this. So when you say, quote, get it through the government, what does that actually mean?
So we've had some clarifications recently, which are really helpful to us. So we do now know, for example, that a private company working with the Department of Energy can help the Department of Energy submit a license application for the disposal of spent nuclear fuel. So that was something we just got a response to that a couple of months ago, and has been a major win for us.
The response from the Nuclear Regulatory Commission.
But there are other issues that still need to be worked through, and we are actively working on those. But yes, it's the government side that is our primary focus right now, I think. And we are looking at, hopefully, there's going to be some talk about this, we think, in the lame duck session. There's going to be an opportunity to look at some of the laws. There's also an opportunity for the Department of Energy to move forward, should they wish, with some other types of nuclear waste. So we're really looking at all of the above.
And we have another question from Twitter, again from Arsalan Khan, who's asking another interesting and potentially very politically charged question. And he asks, so is it possible that first world countries like the US would try to move that waste to store it in third world countries in order to basically get it out of here?
Yeah, I think even in the US, people don't want it transported. Even if it's leaving the US, they don't want to transport it out of their community. So this might have been a fear, but we've done detailed surveys in these states and discovered this fact that the transportation is maybe the biggest issue. Everybody in the business knows it's a big issue, but this is the biggest issue. I think the issue is quite different. I think many small countries are also worried about their nuclear reactors, and in the past they tend to put their nuclear reactors close to the ocean or water where they can get the needed cooling. But in the future, perhaps they should make sure that where they put it, there is suitable geology for local disposal. Because we are modular, if you have a country that has one nuclear reactor, you don't have to build a $100 billion facility like Yucca Mountain. You can put in a relatively small facility that would dispose of it right at the location. So our approach is really very attractive to the developing world.
So where are you now as far as trying to convince the government, and what are the kind of intermediate milestone success metrics that you look at?
Yeah, so I would say we're making really great progress. And we were in stealth mode up until March of this year. So we weren't talking about what we were doing really to anybody. And so it's only been really in the past 6 months that we have started having these open conversations, starting talking to the public, starting talking to environmental groups. And we're making great progress. So we did get this response back to the query from the Nuclear Regulatory Commission, which is tremendously helpful for us. And we expect that we will have more clarifications over the coming months. We're not being public about talking about what exactly we're doing because we don't know exactly what sorts of things we're going to find.
But let me just say, we have people who have been talking to the important congressional committees. We've been in deep discussions with key people in the Department of Energy. We have met, Elizabeth and I have met with the top staff of the Nuclear Regulatory Commission. So we are deeply engaged in the government. We recognize what we're finding are a lot of people there who would like to help us solve this problem, but they have to do it within the limitations of the law. And the laws were written 30 years ago when people just wanted everybody to, Yucca Mountain was the solution. And so let's stop arguing over it and let's just write that into law. And now it's been held back. It's been very slow. Most people believe it will be a decade or decades before waste is actually put there. And so it's a problem. And now you have the laws. And what we would like to do is to find a solution, a way to get the company moving even without changing the laws. But the laws are changing. And the people in Congress all are trying to change the laws. And so we are in contact with them and trying to help them.
So the folks at the Nuclear Regulatory Commission seem positively disposed towards and willing to have conversations with you.
I'm not sure I would go that far. I think the Nuclear Regulatory Commission is looking at how best to implement existing regulations. Right, so that's their job. And so the question is, to the extent that we have clarifications that are necessary, they've been helpful, they've been responsive. But when it comes to changing the laws, well, that's not the NRC, that's the legislature. And when it comes to who's actually going to be in charge, that's the Department of Energy.
How do you navigate all of this? I mean, the landscape that you're describing, the regulatory landscape, is just so complex.
It's been a real learning experience. And, I was completely naive. I still consider myself quite naive when it comes to government and politics. But our very first employee, Sam Britton, is a government affairs expert. And he's been with us now for a year and a half, maybe even about a year and a half now. Yeah. And we recognize that wasn't our space, but this needs to be the space of our company. And if you look at the people that we've been hiring, I think it reflects that.
Yeah, these are people who really see this as a really important, not just national, it's an international problem when you start in the US. And many of these people have been in this space for a long time. And we are really pleased that when we talk to them, they jump on board and say, yes, we want to be part of this. We can help. So we have some, although Elizabeth and I don't have experience, she has a great deal of experience in stakeholder engagement, in community issues, even in government stakeholder engagement. My background is mostly technology, but we've been bringing in people who are world-class experts on these issues, and I think that's really why we have made so much progress.
It's interesting that you recognize pretty early on that the technology solution in and of itself is only you said a third, say, roughly, of the ultimate criteria for success.
And we were told that by almost everybody we spoke to after we showed them the technology. So it was a lesson we learned very early.
And it's also something that comes from our background, right? So, with Berkeley Earth, with our nonprofit, we've always believed in the importance of not just doing something that you think can be done, but in two-way communication and in designing it in such a way that it fits not only the technical side, but also the public perception issues, the community side, the environmental side. So that's something that we have built in, I would say, from day one to our approach, which is very different from the way that nuclear waste has been handled in the past.
Usually it's been dictated centrally from some government.
Yeah, I mean, it's a challenge, right? I mean, knowing how to communicate with people in a way that actually incorporates what they say is a challenging thing to do. And I don't even say, I would just say most nuclear waste efforts. I think most companies don't really do a good job of
that. Yeah, Elizabeth has a background in doing this in many countries around the world. And most of what I know on this subject I've learned from her. But she always says, when you get to a new group, you say a few words, then you start listening. And you listen intently, and you listen to see how could this possibly affect what we are doing.
You learn.
People notice when you listen. And so this is the first step in such an engagement process. And it's a remarkably effective. We've approached some environmental groups that we expected would be staunchly opposed to us. And you listen to what they say.
And they're grateful for that. I mean, they're not coming out and supporting what we're doing necessarily either, but they are having that conversation with us, and I think they're open to continuing the conversation.
Makes sense, especially with such a charged issue such as nuclear waste disposal and its transportation. As we finish up, what advice have you got, or what would you like to say to policymakers and to regulators about this set of issues?
I think this is a really exciting opportunity. We can solve the nuclear waste problem. We don't need to push this off to future generations. We don't need to get caught up into this, the 1980s battle of what we thought could be done back in the 1980s. There's an opportunity here to move forward quickly, to do it in an inexpensive and modular way that really makes sense, not for everybody, So we're not saying this is the only solution out there. We're just creating a new option that some people, some communities, some utilities, some sites may choose, while others, they may choose something else.
You could be part of the solution. This could be part of your legacy. It's something you will be very proud of when you talk to your children and grandchildren.
Well, nuclear, as you said, nuclear waste continues to accumulate, so we're going to have to do something at some time.
Yeah.
And we think that time is now.
Yeah.
Okay. Well, what a very fast conversation this has been. We've been speaking with Elizabeth and Richard Muller, who are the co-founders of Deep Isolation, which has technology that changes the way nuclear waste is disposed, and they're working through the community issues and especially the government issues to try to bring their solution to market. Liz and Richard, thank you so much for taking time to speak with us today.
Thank you, Michael.
You have been watching episode number 302 of CXOTalk. Right this second, please do subscribe on YouTube and tell everybody you know. We have amazing shows coming up, and there's lots of great videos if you go to cxotalk.com. Thanks so much, everybody, and I hope you have a great day. Bye-bye.